Thank you, ma'am.
Now the session is handed to our resource person. Please, sir.
Yes, ma'am. Thank you. Good morning, everybody. This is Pavin Ramalingam, here to deliver an talk over. It's not a talk; it's just a discussion over a machine learning with a tool called Orange. Hope everybody is audible. My voice is audible for everybody.
Yes, sir.
Yeah. Thank you, ma'am. I'm just sharing my presentation. Anyone please confirm whether my screen is visible to you guys. Is my screen is visible, ma'am?
No, sir. Now it is visible, sir. Now it
Yeah.
is shared.
Yes. Thank you, ma'am. Thanks for the confirmation. Uh, I just going to give the basic intro about machine learning, and then we can move about how to use Orange to work on the machine learning algorithms, like major algorithms like supervised and unsupervised learning. So I'm not going to in depth about all the machine learning concepts and theoretical part. I'm just going to give the overview with a very precise manner since you have already attended the machine learning extensively. So I just want to highlight then and there so that our session will be continued based on the headsets we are providing here. So it starts with machine learning. As you guys already aware about machine learning, the main motto of machine learning is automatically learn from the data, right, without any explicit programming. So that's what the hard code of machine learning, which is an again subset of artificial intelligence. This slide will demonstrate us how the machine learning is differ from the traditional programming. In the traditional programming, what methodology, what we will do, we can feed our data as well as the algorithm to the computer, then it will provide the output. Rather, in the machine learning, we can provide the set of data as well as the expected output, and the computer system will provide a model which is the output which is used for uh, uh, future future predictions are for the classification. This is the major difference between the traditional programming and the machine learning. So this one will explain us what is the how we are going to approach the machine learning. If we are going to design any machine learning systems, there are two phases we have to do. The primary one is learning phase, and the second one is the inference phase. What is meant by learning phase is already we are having the historical data. From that, we have to build the model first. As we have seen in the previous slide, here we have to get the input data and we have to feed it to the machine learning algorithms to train the algorithm, and from that it will we can predict the models which one is best for our input. For example, whether we are going to uh, supervised learning, then there are a lot more supervised dozens of supervised learning algorithms are existing. So with our input data, our machine learning algorithm will predict which method will be more suitable for us. Then it will we can get that uh, trained model as the input in the learning phase. That one will be used as the input for the second phase, which is inference. In the inference phase, what we will do, already trained model we are having, which is we can get it from the we got from the learning phase. Then with a new data set, or we can say that a new data set will be fed into the trained model. Then the trained model will help us to predict or classify the input data. This is the way the machine learning algorithm will works in the learning phase as well as in the inference phase. As we have seen in this diagram, the training data, from the training data we can extract the feature, which is a very important process in the machine learning. There is several techniques involved in the feature selection. There are even, we can say that there are a lot more professionals available for feature engineering. So feature extraction and feature engineering is a very critical as well as very important one, which will directly impacting the performance of machine learning algorithm. So from the training data we have to extract the features, then that will be fed into the machine learning algorithm, then we can get the trained model. Then once in the inference phase, which is given below, the test data will be again, from the test data we can extract the feature again, then that will be fed into the trained model, which is trained in the learning phase, then we will get the predictions or the classification. Um, as we all already know where we are using the machine learning and what is the need, everything. And nowadays, each and every complex problem in the data era will be supported by machine learning and AI technologies, right? For example, major applications like image classification, speech recognition, traffic predictions, uh, product recommendations engines, the spam detections, natural language processing, and the self-driving cars, which is um, nowadays they are using the reinforcement learning to test to automatic cars in the market. Then what is the life cycle for the machine learning algorithm? The first phase of machine learning algorithm is the gathering of data. How we can gather the data? Already we are aware that there are several techniques are available in the data mining, as well as the, uh, most of the data mining techniques will be incorporated in the phase of data gathering and the data pre-processing. And even in the data ranking phase, in the data ranking phase, we will what we will do is we can remove the missing values, we can remove the duplicate, we can remove the noisy data, and we can remove the outliers. All this will be handled in the pre-processing and data ranking phase. In the data analysis phase, which is the phase where we can uh, fed the feature into the systems, and the system will be predict the model. This one, which is in the data analysis phase. As we already we have spoken about the terminologies called supervised, unsupervised, and reinforcement learning. These are all the broad classifications of machine learning. Apart from these three, we can have semi-supervised learning or a lot more. But in general, we can say that machine learning will be classified into three categories, which is supervised, unsupervised, and reinforcement learning. We can see one by one. Let's see what is meant by supervised learning. It's nothing but if a system has already known what will be the uh, predictions output, which means the class labels are already known, then that kind of learning system is called as supervised learning. In the supervised learning, already we can aware what will be the kind of output we will get it from our system. So let's say in this below diagram, it's showing the system is trying to identify an apple. So for that, in the supervised learning, already in the learning phase, the system will be fed into different shapes and different colors of apple with red in color. Then in the inference phase, the trained system will be encountered a new apple within green in color with the same shape and same size. From the historical data, it is already learned in the learning phase. From that knowledge, it is going to identify this is a kind of apple, even though the color is not matching. Based on the data, it is already having with the size and its shape. So this kind of training, if we are already mapped the set of input with against a set of output, then this kind of modeling is called as supervised learning. For example, uh, here the labeled data is called as inputs, the input which have a set of triangles, squares, and hexagons, and the system is also fetching or feeding with class labels called squares, triangles, and hexagons. So in this model, not data only is the input, also the label also fed into the system. This is called supervised learning. Here we can know what is the data we are feeding to the system and what is its metadata or its type. So from that, model will train itself and it will give the prediction model. Then if any new test data with one triangle and one square shape given to the system, from the training knowledge, it will predict the square one and the triangle one. So it is already know this system is going to predict only the models already provided, only the data provided in the labels. So if you are feeding any other things other than the class labels, it is not going to predict that model. So in the supervised, this one is called a supervised, where all the input value will be mapped to the particular class in the output. So whether it is a kind of square or it is a triangle or it is a hexagon. So this is called supervised learning. The supervised learning we can classify it into two kind. One is regression and another one is classification. If our data set is uh, continuous, then we will go with regression model. If our data sets are uh, not continuous, then we will go with classification, which is categorical input. We can go with uh, classification. This is an example for continuous values. For example, if an advertisement is 19, that the sale is 1000. If it is goes on, the value changes in the advertisement column will have a change in the sales column. So there is a continuous numeric change in the depends one column depends on another column. So these kind of continuous values will classified under regression supervised models. Uh, there are, as we know already, machine learning algorithms are available with different kinds. So linear models and non-linear regression models. In the linear models, we can have logistic regression, SVM. In the non-linear models, we can have k nearest neighbors, naive-Bayes, decision tree, random forest. So in particular, if we are looking to the regression model, there are linear regression or polynomial regression. If our input data is 2D, then we will go with linear regression. If our input data is 3D kind, then we can go for a polynomial regression. Then support vector machine decision tree, random forest regression, logistic regression. We will take any three of these regression kind of model. We can try to do the supervised learning using the orange tool. It is just saying that what is meant by SVM. The support vector machine, as we know, support vector machine is main aim to um, map the more number of data points inside that hyperplane. That is the main purpose of SVM. If we are using SVM, we can get more number of data points within our systems to train and test the models. As we know, the decision tree and forest regression, the decision tree regression, what we will do, from the training data, the model will generate a decision tree with all the based on the useful features from the feature weightage, which means if we are taking which feature as a root and which one in the leaves of the node, so that our classification will be more accurate. Based on that, the system will identify and it will get the extracted features. Based on that, then it will form a decision tree. That decision tree will be used as a input for our testing model. In contrast to the supervised learning, if we are talking about unsupervised learning, in the unsupervised learning, what we will do is we are having only raw data. We won't get any class labels. In such case, what it will do is in the basic of unsupervised learning, the one data from the sample will be taken. That data will be compared with the another data in the sample. Then it is find the similarity and dissimilarity between the two objects. Based on the similarities, it will group the similar content into one group and dissimilar objects into another. So it is the main thing of supervised learning. If you are not known the input metadata, or we can say that kind of what is the class labels are available in the input data, then we will go with unsupervised learning, where all the data will be compared themselves with the similarity and dissimilarity. It will form a different groups or clusters based on the similarities. High similar objects will be grouped in one. This more inter. The main aim of unsupervised learning is to have intra-group similarity is less and intergroup similarity will be high. That is the base for unsupervised learning model. For example, in this model, we are having set of dogs and cats, but we are not feeding any labels saying that if one this one is a cat and this one is a dog. Rather, we just simply giving all the data, only raw data into the system. Then system will be train itself based on the feature extracted from the input. Then it will what it will do is from the objects comparing the objects between one another, it will get a similarity matrix. Based on that, the model is trained. Once the new test data is fed into the system, what it will do is it will compare the new test data with already having similarity matrix. So the feature similarity, which one is matching, it will be going to group it. So output is set of groups rather than labeled data. It is for the sake we are giving here is dogs and cats. Rather, we won't get any dogs and cats. It is simply unsupervised learning is going to give only the groups. There is two groups it will give. Here also in unsupervised learning we are categorized into clustering and association. The major thing we are focused on unsupervised learning is clustering. The clustering, as I said, high intercluster similarity and low intercluster similarity, which is the main focus of clustering. In the clustering, we can before we are going to clustering, our data should not have any or what we can say. It should be pre-processed with no outliers. If we are having more number of outliers in the unsupervised learning, then our prediction model will not give the more accurate results. So before going to the clustering, the main thing is we have to identify the outliers and we have to remove it. The orange tool will provide a feature to identify the outliers and how we are going to remove it. So we can see everything is in the hands-on sessions. As I said, in the reinforcement learning, it is not kind of supervised or unsupervised. Rather, in the reinforcement learning, it is just kind of the entire simulation environment or the real environment which is given to the agent. Learning agent, what it will do is learning agent will play with the environment, and from the environment it will keep on getting the feedback, which means if let's say we are designing an let's say the car robotic automatic Tesla cars. Let's say if the car is given to the real-time environment where the car is allowed to play with it. Once the car is moving, if there isn't any objects or in the opposite, it should not hit it. So in the initial stage, if it is hits, then that is an there is a feedback given to the agent saying that whatever the movement you did was wrong, so you will get the penalty. So if there is a two roads, if the car has to turn to the right, if car is doing correct, then the system will give the feedback and saying that whichever you are doing is right. So the system will get the agent will get one reward. So based on the rewards and penalty, the system will learn itself. So the main aim of reinforcement learning is to increase the rewards and reduce the penalty. So less in the penalty, which means the system is learned better. So this is the way. uh, Initial stage, if we are running our algorithm, in the first iteration, it won't work as efficient. It is run in the 10th round or in the 15th round. So which means in the each round, the system will get more number of rewards or feedbacks. So it will learn again and again so that it won't, if it is facing the same kind of situation in the future, based on the historical knowledge, it will deduct or it will exactly take the decisions. So that is the reinforcement learning. So as I said in this diagram, the agent is given to the environment where there is an uh, one obstacle is given in front of the car in the initial stage. If it is going and hit, it is getting negative 50 points, right? Which is nothing but it's kind of penalty. So once the penalty is given to the agent will take one step backward. From that, again, it will took what are the opportunities available. There are two options available. One is moving straight and another one is taking right. Already it is taking the step is called moving straight with there is an object. It got an a penalty. So it is not going to take that part now. The second step, the next step, it is going to take an alternative options available. There is an the options available in front of the agent is taking the right. So it is going to take that option. So this is the kind of systems which will be designed for reinforcement learning. So again, this slide is showing that what is the ML algorithm where we can use. As we already seen, for example, if it is unsupervised, there is two kind of things. One is continuous. If it is, we can go for a regression. If it is an categorical output, we can go for classification. In the continuous values, we can use for weather predictions or market forecast, population growth predictions. For in the categorical output, we can identify the medical diagnosis or image classification. Nowadays, there are a lot of research papers are coming in based on the uh, COVID-19 papers where lot of research are based on having the COVID affected chest image with the normal chest X-rays. So based on the supervised model, they are going to classify and without going for the COVID test, based on the X-ray alone, they can able to trying to predict the COVID affected patients. So for that kind of things, we can go for classification kind of supervised learning. Where in the other hand, in the unsupervised learning, if we are go for clustering, we can go for recommendation systems or targeted marketing or customer segmentation. Whereas in the dimensionality reductions or association rule mining, where we can mainly focus on feature engineering kind of things like big data visualization, structure discovery, pattern analysis, all those things will be come under unsupervised associate rule mining things. Whereas in the reinforcement learning, we can go for gaming API, automatic, all the automatic things will be coming under the reinforcement learning. So as of now, anybody has any questions? Shall I continue?
Yes,
Yes,
sir.
sir.
Yeah, thank you. Uh, so far, we can just see the theoretical part. I just want to focus all about this slide, which is very, very important when we talked about machine learning. Even we are working with any machine learning tools, even for Orange, this is very, very important. Yeah. The thing is how we are handling the data. We are everywhere we are talking about data set, and how we are going to use it. So this slide talked about all those things. Uh, let's say if our systems, if we are going to design in any machine learning algorithm, what we are going to do, we are going to take any real world problems, we are going to apply our either supervised learning or unsupervised learning algorithms, then we are going to predict a model. For everything, the base is whatever the data we are having, that is historical data, right? So machine learning is relies on the historical data what we are having. So that is called as a data set. So if we are having a data set, and how there is, as we can, as I shown in the previous slides, machine learning has two phases. One is training, and another one is which is learning, and another one phase is inference, right? So we have to split the data in such a way that we have to, with the historical data we are having, we have to train a model with portion of a data set, and we have to test that model with another portion of set which left. So that with the data we can train a model, we can test. If our results are satisfied, then we can allow that trained model to predict the real what we can say real time data. So if our results are not satisfactory, which means we have to change an algorithm or approach, whatever we have taken, right? So that is the way this one is explained. In the original data set will be classified, splitted into two. One is training set and another one is test data set. So in the training data set again is classified into two kind. One is training set and another one is validation set, where the machine learning algorithm is taking the training data set and it will predict a model. Then the validation test is used to test whether our systems predicted correctly. If it is predicted as for example, we can't always expect 100% accuracy anywhere, right? Even which is not possible. So we can have any threshold. For example, if any algorithm, uh, it's based on the business need. For example, if any algorithm is allowed, if the maximum threshold is 80%, for example, if we are having an machine learning algorithm to detect whether a patient is obese or not, or he is having diabetes or not, then such a case, if the threshold is allowed for 80 percentage, which is reasonable. For example, if it is any critical applications like military kind of army or army data, fraud detections, or cyber security things, then threshold will not allow less than 98 percentage or 97 percentage, right? So based on the threshold, if our validation set is succeeds, then with the final initial test set whatever we are having, with that we can estimate our final performance. If our performance is up to the benchmark or threshold, then we will allow the model to work on the real data sets. So this is the way how the data sets will be used. In detail, we can see how these data sets are worked with orange. There are several kind of techniques called cross-folding or one left out or random sampling. There are several kind of techniques used to work with to split the training data sets and testing data sets, and how we are going to approach on apply on our algorithms. So as we can spoke about lot of data sets from where we can get the data sets, right? So there are a huge number of Data sets providers are available. They are contributed their data sets in the research fraternity or in the uh, let's say machine learning developers or feature engineering or prediction kind of things. They are providing their data sets to publicly available domain for their for the machine learning or AI perspective kind of research works. So there are several data sets available for if you want to go with government data sets or medical data sets or university or colleges, everything will be available in each kind of categories. For example, these are all I have just list out major data sets providers, Google data sets, UCA machine learning repositories, or Google data sets search engines, or Microsoft data engine, uh, the government data sets of India, UK, and US. These are all the links for government data sets. From that, we can get industries or colleges or hospitals of government or private. What are the data with government, which will be given in kind of data sets. From that, we can play it. The computer vision data sets. With that note, I can just stop the theoretical part. Like we can start the hands-on with Orange tool. Um, let's take what is Orange. Orange is an open source tool which developed on top of Python. It's kind of visual programming. Visual programming in the sense there is absolutely no need of coding. If for the initial level, let's say 0% of coding knowledge, if you have, still you want to learn the machine learning concepts, Orange is the fruitful tool, let me say, because you no need to do single line of programming, but with the power of Orange tool, we can play with all the major supervised, unsupervised kind of machine learning uh, algorithms. We can work with that. So, why Orange is quite famous is that as we know, if we want to learn the machine learning or data science, the primary criteria would be the learner should have the knowledge on Python. So, yes, so Python is already having several kind of libraries which works on data science or machine learning or AI kind of things. So, if let me say, ma'am is given profile for me as I was the Java developer, why I have to spend all my time to learn the Python just to learn the machine learning? If I just want to learn the machine learning, for that whether I need to go and learn in another new language, uh, let me say it's more time consuming, and also it's, let me say, for me it is kind of unwanted things. So I'm just going to, I just want, that way I found the RS. I just started to get a tool without any programming language. Then I landed up a tool called Orange. So if for the starters, let me say, if any student or who is learning machine learning at the initial stage, let me say, if they are using the Orange, they can learn the machine learning better and easy without getting that terrific feeling. So it is kind of very easy drag and drop. Already we are having visual programming, we can say it's kind of C#.NET. It's a kind of .NET framework. Already the components are available. We can just drag and drop, and we can design design the flow what we can see, right? For example, if I want to design a page, rather I can't rather writing the code in the plain HTML. I just going to use the .NET framework, and I'm going to take the text box wherever I want, take the labels wherever I want, take the drop downs or whatever things I can just drag and drop. I can organize in a way where what I have to get the form. So I will get it right. So it's just a simple drag and drop rather to write the code. The same thing we are applying in the Orange. We are not going to write any code. We just going to get the components over there. We are just going to drag and drop and we can play with it. The components, whatever we are going to work here is called as widgets. As said before, why orange is we don't need any programming knowledge. We can present the data visually, which is very, very important. And multitude of machine learning algorithms. Yes, I said right. Here we can have more number of widgets supporting supervised learning, lot of widgets supporting unsupervised learning. It is allow for us to do the classification or the clustering. And the, among all, it is a open source, so it's a free. So we don't need to pay anything. Let's say if anyone wants to work with me hands-on, you can parallelly start install in your machine. To install RNs, it's very, very simple task. If your system is already installed with Python, then we can straight away go with pip install command to install an orange flavor. There is kind of different type of orange 2, orange 3, and orange 4. It's kind of versioning, whichever latest you can take. For example, I have taken a year back. So since I'm using Orange 3.2, so this is the way we can install. If you can use the pip tool and you can install directly. It is a kind of standalone tool. Or if you are already working with Python with a different Anaconda navigator, there is an Anaconda Navigator is nothing but it is a set of data science or Python libraries or Python tools which will become under a single package. So it is kind of IDE where Orange also available, Spider or programming or Studio, Python Jupyter Notebook. Everything this will be already available. From the Anaconda Navigator, you can get the Orange tool, or from the standalone uh, package you are having. Let me say I have already installed Orange as part of a standalone tool using the pip tool. Also, to just to show you, I have installed an Anaconda Navigator. I have worked Jupyter Notebook in this already. So Orange is also available as part of it. To just to show here, I have trying to install it. Since already installed Orange, it is taking some time. Let me go with the standalone tool which I have installed. So this is the welcome page of Orange, where uh, things like the another one more major uh, positive thing about Orange is it is having a lot number of tutorial videos, clear documentation, or even examples are available. If you want to see the documentation of Orange, where it will be clearly given the each and every widgets available and what is the input and what is the output and all those things will be given here. Let me say, if you want to see what is the file widgets in the Orange will do, it will clearly explain that what is the use of the particular widget, what are all the kind of inputs it is taking, it is supporting. For example, if you are going to use the file widget, it is allowing .txt file, .csv files, comma separated, tab separated, or XLS. So these are all the allowable input field. With that, you can use and you can explore it. So, so Orange is giving a clear documentation of each and every widgets it's using. So with that, you can use it. And also, if in the documentation itself, If you want to go with any workflows, it is showing that different kind of workflows examples given. From that we can use it. For example, let me say feature extraction. If you want to learn the feature extraction in the machine learning, you can use this example. It is just a let me say it is a bare minimal components and its workflow is given here. You can, to start with, it is a good idea to use any one of the examples given here, and you can uh, go and go. You can design a new workflows on your own. So it is if you want to work with clustering, there is an basic bare minimal example is given here. If it is hierarchical clustering, there is examples given here. So if it is a tree classification tree, there is an example. If it is a PCA, there is an example and with clear documentation. So let me use any one of the example if I can. If I don't have any pre-defined or I don't have any examples to show you, I can use any one of these. So Orange has a clear documentation, and there are a lot of forums available. You can just discuss your business problem, and you can get the workflows already designed. I will say what is the workflow and everything step by step. Uh, like we can start. Um, in the Orange tool, we are having two main parts. One is to on the left side, there are different categories are given, and in each category there are lot of components are here. This is called widgets. Each one component is called as widget. In the white space which are in the right side is shown is called as canvas. Canvas is nothing but the place where we can design our workflow. Workflow is nothing but it's kind of let me say uh, it is uh, uh, this entire thing is called as workflow. Workflow is nothing but let us say it is a kind of solution for a particular problem. For example, the problem I'm here is I'm going to select a particular data, and I'm going to visualize it in the scatter plot. That is the problem for me. Then this is the workflow. How in the file, let me say file is a widget which is taking different format of input. Let's say it is an either XSL or comma separator or tab separator or CSV files as an input. So let me say I'm going to use the tab separated files by default, whichever is provided by the Orange tool. So I can choose the iris datasets. Here uh, we can go the datasets later. I am just going to choose the iris one file, which is nothing but it is a tab separated file. That from the tab separated file, I connect that data into the data table. Data table is nothing but it's kind of rows and columns. It's kind of our SQL tables where whatever the data given in the tab separated file will be stored as a kind of table, so we can easily visualize it. From that, I'm going to see the data in the scatter plot. Scatter plot is a graph, it's a visualization graph. Already we know. I'm going to select, yeah, this is the way I can visualize the data. Whatever the data in the tab separated notepad, let me say if we are having a file in a notepad, always it is very tedious task to work with monotonic Excel sheets or spreadsheets or notepad, TXTs, and manually we are going to work on the raw data is always tedious task. So when if it is in visualized form, it is very easy for us to work, right. That's what we can feel. So this is this is just a scatter plot. If I want, let's say this is, as I said, this is a kind of problem and it is a kind of one solution, which is nothing but all the data which is available in the notepad. I'm going to visualize in the scatter plot. So I just going to select it and I'm going to show it. So you can see it is just a second we can did it. But if you want to achieve it in the any one of the programming language, you can imagine. Let me say if you are working on the Python, we have to read the file, uh, we have to what to say, we have to map all the data into particular rows and column wise. Then that data will be put into the scatterplot kind of visualization tool. Then we have to work on some graphical libraries so that we can do it, right. So all those tasks will be done in a minute, matter of seconds, with just a symbol of few click mouse click movements, right. So this is the main power of Orange tool, where we you no need to mm, pay any attention towards your programming knowledge. Rather, you just going to work on your business. So if let us say if any business analyst in a system, he or she may not aware any knowledge on the programming, right. They are just going to get the raw data. So it thinks is that they have to predict something, or they have to given any business requirement from the data, how they are going to rather they are going to manually process all the files and extracting the relations among them and get the relevant requirement. It's very tedious task, right. Then they have to approach a developer for that to fetch data and process what they want. So it is all kind of extra things. So with the tolerance, if a person other out of programming domain, they want to work on data and they have to predict something, they can easily use the Orange tool and they can use it. As I said, uh, to start with, I'm just introduce what are the widgets and what is this category and all those things. Initially, if you install Orange, you can't get all these categories. You will get only minimum categories like data, visualization, model, evaluate, unsupervised. You can't get associate, spectra, bioinformatics, education, neural networks, data, text mining. These are all extra plugins I have added. Only you will get only few uh, items, few categories, and each categories you will get the all the widgets which are all available. Let me say what is meant with widget. Here, if I can drag and drop the widget in the canvas. That is one way. Otherwise, I can just right click the mouse. I will get the file where we can choose the widget whatever you want, either CSV import or you can go with tree. So either you can drag and drop from the categories, or you can from the mouse clicks we can get it, or if you are using any one of the widget. Let me say there is a difference between this one and this widget and this one. Have you noted in these widgets we are having semi-dotted lines on the right side, whereas only one side, a single either right or left. Whereas in this widgets we are having uh, dotted lines in the both the sides, which means this widgets only yield the outputs. It is not going to get any input. That is what it means. whereas this widget will get input and also it is able to produce some outputs. So this is the meaning of these lines. So let us say if one way we can drag and drop the widgets into the canvas, another one is we can uh, with the right click mouse we can get it, or we can any of the output or input layers, if you click the link, and there you can get the set of relevant uh, output formats. Let's say from the file, these are all the possible uh, outputs or widgets which can accept the file output. That is what it means. Let us say if it is a tree, the output of tree will be taken only by these kind of widgets. These widgets only allowing getting the tree output. For example, rather I am just going to take the file widgets, not the file widgets. I'm, let's say whatever we are having tree viewer, prediction, test and score, email, everything, right? So if I am going to logistic regression, it is take both input and output, right? If I am passing the tree to logistic regression, it won't accept, which means these two widgets are incompatible each other, so we can't able to map it. So this is the way we can have the uh, file, and how we can get the input and how we can connect the uh, things. Another one more thing is, if we are connecting here, this line is known as pipelining. Through this line only the data from the one widget will communicate with another widget. So here if you choose this, double click the link, we are getting the edit link option, where it is giving that file is a widget, one widget, and the tree is an another widget. So there are two kind of inputs in the tree, where one is data and another one is preprocessor. So file output of data will be mapped to another input of data format. So data to data, it is forming. So let me say if we are using scatter plot, from file we can map to scatter plot, right? So if we are choosing, here we are having three things, right? From the scatter plot have three kind of inputs. One is data, another one is data set, and another one is feature. So if we are choosing this one, either you can map all the data to data or data to subset, or if we want to feature from the file, we have to feature extractor or feature. From the features, I'm going to map to the scatter plot. Feature extraction. See, if I'm having any data, or if I'm having any file, from the file I have mapping to the widget called rank. From the rank I am mapping the scatter plot. So in the scatter plot, there are two things. One is reduced data to data, or it is going to be the subset of input for scatter plot, or feature from feature, which means the rank widget will identify the meaningful feature in the data sets. So that feature will be used as an input for the feature. Reduced data is only the data, uh, original data set might contain, there are let's say around 15 features, out of which rank widgets will identify only the meaningful features of 8. So only 8 will be taken, right? That reduced data is from the 8 features and its data. That reduced data will be fed into the data of uh, scatter plot. So, and one more thing, also you can see that there are two lines between rank and widget. So, in such a way, you can pipeline based on your need, one component and another component, and they can communicate themselves. You can see there is an dotted lines, and this one is the double line, right? Which means here already the data is communicating. Here the data is are not communicated. Why? Because here we are not choosing anything. So let's say if we are, why means already we are having reduced data. Reduced data means only selected data. So if we are not selecting anything, how it will show anything, right? So it can't show anything. So to select with, so if I am selecting, see, if I am selecting, the values are populated to scatter plot. This is one. Another one more thing is, if we are doing any change in the one widget, the corresponding widget or the widgets are subsequently connected to the particular widgets will automatically populate the results, which means it automatically update themselves. It is kind of iterative learning. It will iterate themselves and it will find, it will update the things. So these are all the basics about widgets and canvas and the input layers, the how the communication will be uh, happening between the widgets. Let me so the let me just walk through the widgets of each category. For example, data. As the name mentioned, the widgets which given under data categories are working on the data. It might be the input data or data pre-processing. So let us say what are all the things it is supporting. Either a file widget. A file, what it will do, file widget will be taken any file as input and it will give the output. The output will be mapped to any table or scatter plot or anything. So file is supporting, as we can see that file will support CSV file, tab separated, or any files, Excel sheets or spreadsheets, Google Sheets, everything will be used. Whereas if you are using for CSV files, there is a separate component available for CSV file importer. So if you are choosing any CSV file in your systems, then it will take. So file will take, even file itself we can handle CSV, since there is an exclusive widgets available for CSV file input and the data sets, which is very important. Data sets, either all the data we are giving is considered as a data set, or we can use the data set widget, where here, see, in the data sets already Orange is having several pre-defined data sets supported. So from that we can get it. This, you can see human development index. This is the data set. HDI data sets will be taken and its description, and what it will do is, if see the data set size and the number of instance, number of variables given, what is the target value, what is the tags. So each data sets we can see like this. So that if you are using the data set, if you are using the datasets widgets, we can pick the dataset from the orange. So it's a dataset widgets. SQL table, yes, SQL tables. If uh, your local, you are having any SQL server, you want to rather taking the values of SQL queries, you can directly give the instance, server instance, user ID, password, and connector, and whatever the tables you want to display, you can use it. So SQL tables are provided, data tables, paint data. Paint data is nothing but it is kind of, as we can see that for the clustering, always it's a kind of graph we are giving, right? So paint is nothing but just a canvas where we can, from the mouse, if I right click, I can get the dotted points. Or if you want to glitter it, you can play it, or it's just a kind of, what we can say, it's kind of rough usage. And if you want, for the teaching fraternity, if you want to teach something kind of practical oriented for clustering, or random sampling, we can use this one and we can play with it so that it will be quite helpful. If I want to drag some points over C2, we can use the brush option. I just pointed few C2 elements, right? If I want C1, I can brush it. If I want C2, I can brush it. So if I want to move the points then and there, so I just spreading all the data points over all the area of, so likewise it's just a paint input. This widget is used to paint a, we can just paint and we can use this as an input for the algorithms, right? Then data sampler, which is a widget where data sampler, as I showed on slide, where we can have a data set. From the same data set, we have to split for training as well as the testing, right? So data sampler is used to fix that one. How many percentage of data will be used for sampling, which means which will be used for training, and which is portion of data which will be used for testing. For example, if we are giving 20% for sampling, then our 20% of sampling, then 80% will be used for training and 20% will be used for testing. So those kind of things. If it is a cross validation, in the cross validation, we can use 10 subsets. 10 subsets is nothing but the entire data will be split into 10 groups. 10 groups of data. From the each group will be taken as a training data set, and one unsubset will be used for testing. So this kind of fixed sample size. For example, fixed sample size. If the instance of a data set, if we are having 2000 entries in a data set, how many samples we are used for testing or training. So for example, if I am giving 200 out of 200, if I want to choose 150 instance for training, then all of those things will be defined in the data sets, data widgets called sampler. Then select row and select columns, which is very, if there is a, let's say there is, in the iris data sets, we are having 5 rows and 150 columns. If I just want to work only with a few columns, I can go with select columns, where I can select. So in the select columns, I can go with this, whether what are all the columns I in our data set. In our data sets, we are having 5 columns, out of which in the select, using the select column, I'm going to use only sepal length and sepal width. Then this data, we can see the values in the data table, or in the data table only we are having sepal length and sepal width. So, and the iris classification. So if you want no need of using the selected, we can remove it. It's a kind of meta attribute. So we can see this. Now only we are having the class labels and with 2 columns. So like way, this select column will be used when we are having, as I have shown, if we are having 20 plus features or columns, which means each column is representing one feature, right? Feature of a data sets. So if we are choosing out of 20, if only we can find using the rank methodology or PCA. PCA will be used for identify the principal component, which is used dominantly for the classification or clustering. Then only instead of working on the whole data sets, only the components or principal components which we have selected from using the PC analysis, only that column will be selected and that will be fed into the system, which will be more accurate, right? So, so for that we can use select columns. Likewise, you can use the select rows. Let's say rank. Yeah, rank is an very very important widget where that rank widget what we will do is based on the, let's say I am put the value to the rank, what it will do in the rank widgets based on the different scoring techniques. As we know, information gain ratio or information gain or psi square or FCBF or Gini index or Gini decrease. So these are all the predominantly used scoring techniques. Based on the scoring technique, it will compute itself and it will give the results in which techniques you can use so that you will get the better results, better accuracy, right? So based on that, if I'm taking the petal width as a feature, then the gain ratio is 0.54, whereas petal width is 0.52. So it's kind of rank our features based on the different scoring techniques we are using. As we know, in the decision tree, we are using Gini index or information gain ratio to construct the decision tree classifier, right? So if you are not aware about what is chi-square or relief F, it is just a mathematical thing. You just go and see how the information gain is computed or the information gain ratio is computed for the particular column. So what I am trying to convey here is uh, see how uh, things are easy here. For example, if, to compute or to solve a decision tree problem, we have to compute the gain ratio. From that, we have to compute gain information gain. From that, we have to uh, calculate information gain ratio. After that, we have to construct the tree. From that, we have to what we can. So we have to optimize the tree using the Gini index, right? All those things manually we have compute, right? So all those things are already available as just options in the uh, widgets. We can just use whatever you want. So from this we can get that whatever the value we are computed. From this we can say this. These are all the petal length and petal width are the two predominant features with high information gain and high Gini index. So if our decision tree or any principal component taken as a petal width and petal length as the important feature, then the classification or regression will be more accurate, right? So for that, rank widget will be used to rank the things. Then correlations, everything, outliers. As we know how to identify what is meant by outliers. To identify the outliers, we can have the widget called outliers. Even we are having paint, as I saw, colors, different colors. We can give feature statistics, neighbors, feature constructions, Python script. Yeah, this one is very very useful widget. What is Python widget is, as I said, here we no need of any programming language. Uh, you are thinking that yeah, Python Orange is providing a lot of widgets, but I am not convinced in this one. My business problem is not solving the widgets which are all provided here. So I just want to already there are several kind of widgets available. With this, I want to design my own user defined widget. Then that widget will be I have to use as part of Orange tool. Yes, we can do it. Or I just take essence or pre-processing or whatever things provided by the orange widgets, but my business core logics I'm having as part of Python script already, or I'm coded with Python script, then the output will be visualized rather in something else. I can directly use the widgets using the visualization widgets provided by the Orange. In that case, for example, this file will be given to the Python script in such way. There is no need of Python script to read the file data or input process the data. Rather, the data will be already given to the input for the Python script. See here in the Python script, from the data, it is giving this I data, I datas, I learners, I classifiers, I objects. These are all the inputs already given as part of the input variable. The output from the script may be taken as out data, out learners, out classifier, out object. Here we can have our business logics written. Then that logic will be used. Either I can visualize it or I can use it for classification or ranking, or I can compute the distance between. So this way, I can, if my business logics, if I want to compute something else, we can use it. So for that, we can use the Python script component. These are all used under the data, where in the visualization, uh, as I shown, it is giving all the graphical representation mostly used in the machine learning, either the scatter plot or distributions or box plot, previewer, linear projections, Slaton plot, and nanograms, Venn diagrams, heat maps. So all the visualization components are already available. As already I have shown the scatter plot, now let me show distributions. For example, I want to see the data set in the distribution. From the distribution, I just want to know from which column I can choose, so that for that I'm just explaining data set. Yeah, it is an iris dataset. It's a quite famous dataset. Every example is using this one. It's nothing but what is in the iris dataset is nothing but based on if we are taking any one flower, based on the sepal and petal width and length of the flower, it is classified into three different groups, either iris setosa or versicolor or virginica. It's kind of categorical. So if any input is given or any feature is given based on the image or based on the features of petal, sepal, length, and width, it is going to classify it. That is what this that as it is all about. So in our distribution, what we have to do, the main problem of this data set is to classify three different groups or categories called Setosa, versicolor, and virginica, right? So if I am taking petal length, sepal length, or sepal width, how it is classified. For example, if I am taking sepal width in the distributions, I can see that all the samples are overlapping, right? For example, iris virginica is overlapped with IC vesicolor, and IC vesicolor is overlapped with IC setosa. So this is not the feature we have to choose. So if I am using supple length, yeah, it is better than the supple width. But since there are few few regions are overlapping. So if I am going with petal width, yeah, it is iris setosa alone at least separately classified or separately grouped. So if I am going with petal width, so in this way we can visualize the data and we can see which one is the better one. For the visualization distributions we can use, as I said, if you want to see the tree, for example, if I rank, if I want to construct the tree and I have to view the tree viewer, see how simple it is. Just drag and drop. It is uh, it is constructing the decision tree, right? Let's say iris setosa. See here, petal length, petal width. This is the feature. If we are taking the petal length, which will be classified better, as we can see here also. If yeah, in the orange we can see the widgets parallel to each other's. See here, decision tree saying that if you are taking petal length as the feature, it is classifying the iris setosa separately, right? Petal length. The same thing if I am choosing the petal length. See, iris setosa is separately classified. So like way, so we can just see the we can easily able to see visualize, or we can easily do the classification things or all the machine learning complex things in a just a single drop and drop. So it is a tree things and box plot, or for example if you want to linear projections, yeah, let us project our data in the linear projections. See, in the linear projections you are just going to project our data either in the 2D plane or 1D plane. So these are all the whatever the visualization projections you want to make, you can do all these steps. So if you want to color or shape, size, change, anything you can do. We can optimize it, we can change it. So these are all just if you want to show color regions, this is the way it is classified or grouped. So color regions are given. So here in the orange we are in the sorry, left corner we are having the options called save image. Excuse. If you are having the option called save image, also from that, if any you are for example, if you are having any, if you are modeling anything or you are feeding data, you want to record our results, you can just projections are you can write any graphs or scatter plot or linear projections or a tree viewer, anything, and you can just give the option called save image. It will save. So lot more features, lot of the things are available in nanograms. So I'm just showing nanograms. Targeted class. What is the target class? Nanograms. Okay, nanograms. I'll show it in another example. Venn diagram. These are the visualization tabs. Let's go with another tab. Which one is very. I'm just deleting a few things just to make some space. Yeah, in the evolve in the model. This is the place where we are getting different kind of models. Machine learning is already supported. For example, Navy base, neural networks, or logistic regression, or SVM, or linear regression, or KNN. So let's say we are having one data set, right? I just want to know if I am taking which model so that my algorithm works better. So how I can do is I just so basically this the important thing what we have to notice We no need to develop all these models manually or in just supporting. We just drag and drop. See here, if anything like this, which means there is an error, which means continuous class with target class. Whereas in our data sets, our target class are the categorical outputs. So if it is a categorical output, linear regressions are not suitable. So it is just a thing of you can recalling the machine learning techniques. So what here is we are having different models. We can get those things test and score. Test and score widget is as part of evaluate. I will explain it. I will explain you what it will do is the test and score. It's very important to see this. I am having different models. I don't know which model I have to use for my data sets. Then what I will do is I simply connect my data into the file widgets and I'm just drag and drop all the models and I'm going to evaluate it, test my data sets, and I'm going to find which model is more suitable for my data sets, which means these are all the important parameters we have to see. For example, area under curve, which represents how many data points are included, which is not under the curve, which is not an excluded for the excluded as outliers, and classification accuracy, FMSS, precision, and recall. These are all the very important parameters in order to pick which one. For example, for us, if our classification is very classification accuracy for us is very important, then we can go with algorithm which yield the better classification accuracy. Or if we want to uh, map all the data points, since it's very prediction kind of things, it's kind of let us say real estate or economical kind of predictions saying that gold rate or everything. So we can't omit any one of the data sets because all the data sets will be removing few sampling data samples which will vastly impact that results. So in such case, we have to go with a model which is works better, which will have the more area under curve parameters. So based on that, if we are work on any text mining things or sentimental analysis, neural natural language processing, then we have to focus on FMSs, precision and recall. So based on our business need, we have to think which model we have to use. As simple as that for as of now, I'm just going to say that the model which have high classification accuracy. For example, among the results, we have seen SVM have the 0.960, 96%. Even logistic regression have 96.7 percentage of classification accuracy. So I am choosing that for these data sets, logistic regression is the best one. So I have to choose logistic regression. Here uh, I am saying that I have used all those things, but I have to save the model. Once I have tested, I have to use this model for future things. Again, I no need to work the same data set, and again, I no need to uh, train the data sets again. Then, such case, you can use the save model widgets. Okay, save model widgets. Save model widgets is under the model category. The save model widget, what it will do is, it will save this model as already trained one. This data sets, iris data sets, is trained using the logistic regression, which is yielding the more classification accuracy that we got right. So this model will be saved, and for the testing, rather use again all this model and choose which one is the best one. I can just use the saved model. I can just take it. For example, I am going to save this model. Yes, I am going to save it as part of orange one. I'm saying test. I have saved. So once I have saved, I am going to use the load model widget. I'm going to choose desktop orange test PHP. Yes, I have chosen right. So rather to model all those things, I'm just going to connect. I'm just going to use this for predictions. For predictions, we need to use the data. So the training is done, the trained model is saved, that even in the future I no need to use the save again I no need to train the systems. So I am just going to use the trained model which is saved earlier, which will be loaded using a load model. Then that load model will be fed into the predictions, and the predictions will give the results. The prediction results is showing that how the data is predicted using logistic regressions which we have saved earlier. So this is the way we can use the save model or load model, yeah, stacking, which is another one important component. Why is it necessary in saying that only the model already defined, which means one network or SVM, logistic regression or SVM yield the better results. Rather, combination of any of these models might give the best results, right? So to compute that one, we are having a fantastic widget called stacking, where I have stacking will be loaded to the learner. One more thing here is now it is computing something, so it is not loading the data. Let us wait. It is not taking. Something happened here. Learning, tagging. What's happening here? Learner to learner. Okay, well, let me see what's happened here. Actually, staging is a widget which is going to compute which one is the better one, or combination of which one is yield the better one. So that is the thing it will do. Neural networks, yeah, we know, right? In neural networks, how many iterations, how many hidden layers you want to use, all those things we can use, and which solver we have to use. So we know need to compute things, we can easily configure things, and we can see the navy base, logistic regressions. So in the regression type, which one you are using, or in the support vector machines, what is the VSVM or SVM, what is the cost, regression loss, so kernel, which kernel you are using, so how many iterations, number of tolerance parameters. So all those things, if it is a KNN, what is the number of neighbors we have to use, which metrics we can use, either Euclidean distance or Manhattan, or which which computational methods which computation methods we are using. So we can choose, we can either increase it or decrease it. So based on it, KNN results will get varying. So for iris bits, if it is a KNN is 3 or 2, the results computation accuracies are changing. See now, previously we are seeing that logistic regressions yielding better results. Now both the logistic regression and SVM yielding the better results. It is kind of trying the same data again and again. It's getting tuned again, so the results are varying. So these are all models, some of the widgets in the model. So some of the widgets in the evaluate, I have shown the widgets called test and score. Test and score is nothing but it is going to, what it will do is, it is just taking the values, different models and the data as the input, different models like KNN, these things, and data as the input. It will compute either of the sampling methods, either the cross validation or random sampling or leave one out, test on the training set or test on the sampling set, everything, all the combination, and it will give this metrics based on AU, CA, F1, precision or recall, and that's the thing test and score will do. Whereas prediction is a widget which is used, uh, the prediction results which is used to both the test and score. And the testing dataset and the training datasets, we are having all the datasets. Yeah, if the predictions will take model and the data as an input, and it will give these based on the navy base identifier, if it is an iris vesicolor, how it is identifying, whether it is in the retin color is showing that, uh, see in iris, actually I have chosen iris setosa, where few iris vesicolors are classified as iris setosa. These are all called as misclassified labels. So if you want all those the prediction things, we can use the prediction widgets. So confusion matrix and rock analysis. These are all the two very important metrics in the machine learning. One is confusion matrix. For example, test and score will be connected to the confusion matrix. Yeah, confusion matrix, which is used to identify the true positive and true negative, which is sensitivity and mm, sensitivity things like that. For example, if it true positive is an important parameter, when if what is my true positive? True positive is nothing but if we are taking the number of samples, let's say if we are identifying a particular data set, it is an adult or not. Let us take there are 20 data sets, then uh, among 10, 20 sets, there are 10 adults and 10 children, which means if it is an actually the prediction model, if we are taken, for example, if we are taking navy base as the prediction model and test and score, what it will do, it will just in the confusion matrix, what it will give is this value. For example, if iris setosa, this is the predicted, this is the actual results. Actually, the results is 50. Among 50, only 49 are predicted correctly, which is called as true positive, which means actually iris setosa for among 50 true, only 49 are identified, which is called as true positive. Then the misclassified ones called as uh, true negatives. Whereas in the iris vesicolor, uh, uh, among true negatives are identified. In the true negatives means uh, actually seven are iris versicolor, but it is classified under as iris versica. It is nothing but it is a uh, false positive. So, so true positive and false positive are the important terminologies which is worked on the confusion matrix. So, in the based on the confusion matrix, what we can say is whether we are going with our business problem focused on the true positive or it is focused on the true negative. For example, when we will go for true positive cases. For example, if we are going to identify the COVID cases, if our X-ray chest images has to identify which one uh, in the business problem, which one is important, whether true positive or true negative. For example, if a person don't have a COVID, even he is classified as a COVID, has not an impact because he is just going to take an additional medical test, and if he is not sick, then it is not fine. That is fine. But if a person having the COVID is not identified under the COVID, he is under identified as a normal, then that is a crucial case, which means he can spread the COVID, right? So in that case, true negative should be zero. So the algorithm which yield the true negative as zero has to be taken as a model. Or if we are identifying, for example, particular person is a obese or not, or obese person has a diabetic or not. In that case, we have to focus on the true positive. Since if a person don't have a, if a person have a diabetes, has to be identified. So in that case, we have to, based on our business need, either we have to go with the true positive case or the true negative case. So based on in which the confusion matrix, whatever we are giving with different things, we have to choose which one is the best one. So for that, we have to use confusion matrix. Whereas in the rock analysis is also a kind of um, it is also a kind of evaluation technique where we can see for the iris virginica classification, we are having we have used different classifiers, among in which the which classifier having the uh, true positive rate, that is the sensitivity, which one having the higher sensitivity has to be the best classifier. Let us see the line which is comes closer to the true positive rate lines, and to me this one is the best one. So let us say this one and this one are the best classifier. So the classifier which is given in this color is not useful, since it is not aligned with the lines of true positive. It is far away from the true positive lines. So rock analysis is used to identify like this. For example, navy base. Navy likewise, KNN is also the best classifier as far the rock analysis is concerned. Whereas in the neural network, which is also not a good classifier, there are two classifiers which are all come closer to the true positive. So which is very important. That is SVM and the logistic regression. The same results we can see it in the test and score, right? SVM and the logistic regression has the higher classification accuracy. The same thing we can see it in the confusion matrix. These are all the different metrics which will maybe based on logistic regression, which is giving the more true positive cases. For example, 50, 47, and 48. whereas KNN gives 50, 45, and 47. So these things we can see using the evaluate metrics. Then unsupervised, this is the widgets are, I'm just clearing everything. These widgets are used to support the unsupervised learning. In the unsupervised learning, the first thing we can get it in our mind is what is called as clustering. So K means clusters, hierarchical clustering, ECA, distance. The main thing for the clustering is identify the distance. Distance is the matrix used to find the similarity and dissimilarity. Okay, so the similarity between the points is noted as the distance matrix. So the values in the distance is lower, which means they are more closer. So for clustering, we have to first compute the distance matrix. Then we have to use that distance matrix for the classification. So NDS or DB scan, distance map, distance matrix, distance transfer, these are all the widgets supporting unsupervised learning. Okay, we will. I'm just now briefing what is the use of widgets. We will use these widgets. We can create few workflows and we can demonstrate in the afternoon session. Okay, unsupervised learning. Whereas, as I said, uh, in the morning, in the starting of the session, you can't get all these kind of categories. You can have once Orange is installed with bare minimal categories like data visualization, model, evaluate, and unsupervised. You can't get biometric or educational, geo, network, text mining, and all those things. These are all called as additional installation. Let me show how to do that. You have to open the Orange with administrator privilege to install the new plugin. For example, in the options tab, you are having add-ons. So if you go for add-ons, it will list all the add-ons which you want to install. For example, already I have installed all these things. I have not installed the Explain. Explain is a new category which is given. So I have to install it as single cell. So for its sake, I'm just installing Explain now. Explain I have chosen, so action is installed. So other things are already I have installed. So if you given the install, it will download the components widgets from the uh, from the Orange, and it will add as a new category. Then we can use the widgets comes as part of Explain. Let me download it. Once it is downloaded, we have to restart the Orange. Once the Orange is restarted, we will get, see, Orange needs to be restarted once the change to take effect. Let me say okay. See here, there is a no category called Explain. Okay, so once Orange is restarted, see there is a new category called Explain, where explain a model or explain a prediction. These are all the two widgets supported under the Explain. We can see how we can use these two in the subsequent session. Okay. So let us, likewise, I have installed a few things. Let me say for image analytics, for image classification and clustering, we need to import the image, like usually whatever we have seen so far is the kind of raw data with tables or tab format or comma separated, all those things. For I need to either classification or clustered image, then I have to install the image analytics. where you can use the image viewer, image embedder, image grid, or save image. For example, import image will take the images as the input, and it will give the image viewer to display the images. Image embedding is a very important widget which will just extract the features from the image. So that will be done in the widget called image embedding. See, image embedding, actually it will use either of these image feature extraction techniques. For example, Google Inception v3 model on ImageNet, which is a very useful machine learning model, which is which was used for uh, fraud detections in the Facebook, or even in the Googles. They have used Inception v3 for image identification. So either you can use it, or you can have any different kind of things available. So you can use it. So from this, for example, if I am using image embedding Inception, Google Inception v3, it will embed. For example, if I want to select an image of particular folder, see, it is showing that if I import few images, it is showing that images of 27 images of two categories are loaded. See here, it is embed the image, which means all the images will be analyzed using the Google Inception v3. Then it will extract the features. Once the image embedding is done, we can see what all the features were being extracted from the image. Let me show you what is the image I have used. I have just used. Let me open in the. See, these are all this folder containing the images, few paintings, few paintings done by Manet, and few paintings on Monet. Okay. These images will be fed into the Google Inception v3, and Google Inception v3 is embedding this. See, it's still embedding. Embedding is nothing. It's just extracting the features. Okay. Okay. See, we are giving only Manet, Monet, and the image name, image size, image locations, image width, height. These are all the values. Yes, we can able to extract, but from N0 to N0 to N99, there are 1,000 different features were being extracted from the images whatever we are given using the Google Inception v3, which is which is done in a matter of seconds by using the image embedding widget. So for the image classification clustering, the widgets which are all given under the image classification will be used. Likewise, if you are analyzing some time series kind of data, for example, any ECG or anything time related or frequently varying data, we can use all these Yahoo Financials or moving spectra images or ultrasounds. Whatever we have to analyze, we have to use the time series. For its textables, again, it is more kind of transform the text or URLs, text files, text fields, pre-processing, converters, all these pre-processed kind of stuffs for the text will be given the textables. Whereas in the text mining, where which is another important things, rather getting all the data in a kind of data sets format, I can either get it from the Wikipedia, or I can get it from the Twitter, or I can get it from the documents, but bunch of documents which are all I'm having, or document map, or uh, or even from the NY Times, the Guardians, from the corpus, or these are all the different source from where we can get it. For example, if you want to connect the Twitter, you have to give the Twitter API key and secret. As of now, I'm not giving. If you are having API key and uh, a key and secret, then you can directly querying it from the Twitter. You can fetch all the data. It is very useful when you are working on areas like sentimental analysis or natural language processing. So rather pulling the data from the data sets, you can directly take the data sets using uh, Twitter widgets in the Orange tool. From it, you can directly connect it and you can extract the data from which you can have cool features like features. You can do the sentimental analysis on it. Uh, you can ask the Twitter profiler. Yes, if not only analyzing the Twitters, you can even analyze the profile of each tweet. Who is owner of the tweet and who is originally writing the tweet, who is actually what to say, repost it or liked or commented, or which location the actual tweets has to be written, and so all these things you can from the Twitter profiler you can get it. So all these kind of even more complicated business things or crucial things will be handled in simple matter of widgets. So then next widgets we can see is network. If you are working on the simulators, network simulators things, you can use it. I'm blindly saying that from this widgets I can't use anything because I don't have any knowledge on this network simulations things. For Geo, yes, for Geo is kind of map, real world map things. We can do it. Yeah, I will explain this Geo things with COVID data. I will show, explain just now I have seen. Yeah, educational, for educational things, either we can use Google Sheets. Yes, Google Sheet is used for getting the any yeah, rather showing that already available datasets, we can simply giving few pros and cons Google Sheets and we can feed into it. We can use it in the Excels or things we can do it, right. So those things will be come under the educationals, either iterative k-means, yes, k-means clusterings. In the iterative k-means clustering, there are a few cool features which I will show in the afternoon sessions where how the iterative tables will be working on its kind of graphical simulation. We can do it in the iterative k-means things. Then polynomial regression, polynomial classification, pie charts, random data, all those things will be come under educational. Wherein bioinformatics, where we can go for widgets with work on the genetics or gene expressions or um, those ones. These things, these two I am not aware. Then in the associate frequent item sets and association rule mining and spectroscope, where we can have all these things for spectrum analysis kind of things. These are all the different widgets available on different categories. So, so far, this is all about introduction to all the widgets and how we can use it. Yes, this is what we have seen. For data, what are the widgets we are having? Yeah, there is a separate component for unsupervised learning that we have seen. For supervised learning, we are having the things under model or neural network, stacking, SVM, random forest, Navy-based logistical regression, linear regression. These are all the widgets used for supervised learning. And as I have shown here is how we have to divide our data sets for training and testing. It's always 70-30. It's a good, the rule will be called as 70-30. 70-30 is nothing but 70% of data will be used for training set and 30% will be used for testing data sets. So I have shown the evaluation metrics where we have to more focus on the parameters like accuracy, ROC curves, false positive, false negative, and sensitivity. Test and widgets. I have shown what is cross validation, what is leave one out, testing on training set or test on test set, random sampling, all those things. As I said, either we can develop an orange tool, orange widget, and we can add it as a component, or we can have we can one more thing we can use orange inside the Python library rather using Python code inside the orange tool. We can use orange widget inside the Python code. That you will do. You can just import as like other libraries. You have to use import orange. Then orange widgets will be available in your code. You can just instead of using the graphical representation, if you are more comfortable with Python code, yes, you can do it. That too possible. So with this theoretical part I have covered. If anybody has any question, please let me know.
Participants, if you have any queries, kindly ask. Okay, sir. So no queries, I think so.
Ma'am, session continuing or
Sir, we will start the session at 2 o'clock, sir.
okay, ma'am.
Okay, sir. And kind information to the participants. Few participants haven't given the feedback for yesterday's session, day 4. So please, those who have not given the feedback for day 4, please complete the feedback within half an hour. It will be closes within half an hour. Thank you. Again, the session will be started at 2 o'clock.
Thank you, ma'am. Shall I leave, ma'am?
Okay, sir.